Hello students, today we will study about laws of refraction. Now similar to the laws of reflection, there are also two laws of refraction. So the first law says that the incident ray, the refracted ray and the normal to the interface at the point of incidence all lie in the same plane. That means we have seen that the incident ray, the normal and the refracted ray, they all lie in the same plane and also at the same point, which is called the point of incidence, right? Next is this is the Snell's law, very important law of laws of refraction. That is the ratio of the sine of the angle of incidence and the sine of the angle of refraction is constant for a pair of given media. That means sin I by sin R will always be constant for a particular given pair of media. Okay, sin I means sine of angle of incidence by sine of angle of refraction. So this value is a constant, and this is called the Snell's law of refraction. So 1 mu 2, mu is the refractive index. It can be also written as n in some books, so don't get confused. Mu and n both are same, they are refractive index. So 1 mu 2 is refractive index for medium 1 with respect to medium 2. Now let's see what is refractive index. So the refractive index of a medium for a light of given wavelength. So if you take a light of a particular given wavelength, it may be defined as the ratio of speed of light in vacuum to its speed in that medium. Now suppose you are taking the light, you are finding out the refractive index of light in glass. So how will you find out? Mu will be speed of light in vacuum, which is always 3 into 10 to the power 8 by speed of light in glass. Or if you want to find out in water, so mu will be speed of light in vacuum by speed of light in water. Okay, so basically it is the ratio of the speed of light in vacuum to its speed in that medium, means in any medium. So mu we will write as c by v, where c is the speed of light in vacuum and v is the speed of light in that medium. Now since mu is a ratio of the same physical quantity, so there will be no unit. So refractive index does not have any unit, very important point. Okay, next we will see a refractive index with respect to vacuum is also called absolute refractive index. Okay, now speed of light we know is c. Now speed of light we have studied in class 9 also, that speed of light is frequency into wavelength, nu into lambda, where lambda is nu means frequency and lambda in vacuum means lambda vac we have written as lambda in vacuum or wavelength in vacuum. Also the speed of light in any medium will also be written as frequency into wavelength. Now the wavelength changes from medium to medium, but the frequency remains same. So in different mediums the wavelength will change, and because of the change in wavelength of light, the velocities or the speed of light also changes. One thing which always remain constant is the frequency of light. Okay, so V will be equals to nu into lambda of any medium. So mu means refractive index. We have seen that mu is equal to c by v. So c from here we will substitute c from this equation. C will be lambda vacuum into nu and v will be lambda medium into nu. So we can cancel out nu from both sides. So mu will be equal to lambda vacuum by lambda of medium. So another formula for a refractive index, this is one formula, mu is equal to c by v. Another formula for refractive index is mu is equal to lambda vacuum by lambda medium. In some books it is also written as mu is equal to lambda 0 by lambda, where lambda 0 denotes the wavelength of light in vacuum and lambda denotes the wavelength of light in any other medium. So here we can define refractive index. Refractive index may be defined as the ratio of wavelength of light in vacuum to its wavelength in that medium. So this is another definition of refractive index. So we have two definitions. This is one definition and this is another definition.